So it says on a map, Orlando is 178 millimeters due south of Niagara Falls. Denver is 273 millimeters from Orlando. And Denver is 235 millimeters from Niagara Falls. Find the angle at Niagara Falls. Okay. Huh, I see this written here, easy. Okay, so let's draw the diagram for this.
Yep.
South of Niagara Falls. So let's say that here you have Niagara Falls. Niagara Falls. This point is Niagara Fall and 178 millimeters south. That, let's call it Orlando.
Yeah.
And then there is Denver, which is 273 millimeters from Orlando. Okay, and Denver is 235 millimeter from Niagara Falls, so it would be somewhere here or here, it doesn't matter. Let's say here you have Denver.
Wait, why is 178 between N and O?
Why is what between N and O?
178.
Because it says Orlando is 178 millimeters due south of Niagara Falls.
Oh, okay.
Okay. Then Denver is 273 millimeters from Orlando, and it is 235 millimeters from Niagara Falls. Okay, so it will be somewhere here in between Niagara Falls and Orlando. And if we take the scale into account, 235 is almost double of 178. So let's draw it somewhere here. Okay, so 273 from Orlando. Here you'll write 273. This is Denver, D for Denver, and it's 235 from Niagara Falls. Okay, find the angle at Niagara Falls. This is the angle that we have to find out.
Okay, so we should use law of cosines?
Law of cosines. Okay, first of all, we should label the sides and angles. With the notation that we are familiar with, A, B, C, and capital A, capital B, capital C.
Mm-hmm.
Okay. Okay. So I'm going to call this as A, B, and this as C. So this will be capital, this is capital A, this one capital B, and this one is capital C. Okay, and we have to find out angle A.
Mm-hmm.
Okay, and we have all the sides. We have small a, small b, small c. Okay, so for angle A, you will write the law of cosines. A square is equal to b square plus c square minus 2bc times cosine of capital A. Now, it's all about identifying which law should we use, right?
Yeah.
Should we use law of sines or law of cosines? Here, we are not using law of sines because we will need one more angle to use law of sine. Both the laws, right? Law of sine and law of cosine.
Yeah.
Okay, so now here we have all the values. Small a is 273. Small b is 235. Small c is 178. Minus 2 times b is 235. C is 178 times cosine of angle A. We don't know angle A, that's what we have to find out. Okay. Now we'll need our calculator.
Okay, so
74,529. Then 235 square is 55225. And 178 square, 31,684. Minus 2 times 235 times 178. 83,660 times cosine of angle A. Okay, let's subtract. So 74,000. I think these are now just calculations. You can do these.
Yeah.
5 minus 31,684. It should be negative. So you'll get negative 12,380 is equal to negative 83,660 times cosine of A. So divide both sides by negative 83,660 and then take cosine inverse.
Mhm.
That will be angle A. Angle A will be cosine inverse of negative 12,380 all over negative 83,660. Okay, so this was easy. Did you write this easy?
Yeah.
Okay. Then we have Nicole shines a light from a window of a lighthouse on a cliff 250 feet above the water level. Okay.
I was
Let's
struggling. I was struggling with this.
Just let's draw. So there is a window of a lighthouse on a cliff. This is the cliff. Let's say this is whatever is the height of Nicole. We will consider that that is 250 feet above the water level.
Wait,
So
what?
there is water. Then in water there is cliff. Then on the cliff there is a lighthouse. Right?
Okay.
Okay. Let's draw the water level as well. This is the water level. Then on water, there obviously the cliff is on in water, and then on the cliff there is the lighthouse, and then in the lighthouse there is the window. Okay, and for all of that, it's given that on a cliff 250 feet above the water level. So this 250 feet is the height from where Nicole is shining a light. Let's call that this is the point. Here is Nicole, and this height is 250 feet. And remember, in the final answer, okay, this is an angle, so the answer will be degrees. But if you have to find out the length of a side, then don't forget to write the units.
Yeah.
Okay, then there is Nick, 10 feet above the water level in a ship offshore, finds that the angle of elevation of the light is 3 degrees. Now you have to draw Nick 10 feet above the water. This is 250 feet, so Nick will be somewhere here. 10 feet. Well, it will be much, much smaller than this. So I'm not considering the scale. So let's say here is Nick. And this is 10 feet. Okay.
Yep.
In these word problems, if you draw the diagram correctly, then 80% of your question is done correctly. Then rest of the things is just 20%. Okay. Now it says that here, this is the important part. He finds that the angle of elevation of the light is 3 degrees. Now, which angle they're talking about?
The angle where Nicole is.
Hmm.
So,
Now,
hypotenuse.
so I'll connect these 2 points. Now here as well, there are chances of making a mistake. Now you see that there are 2 angles. Are we talking about this angle or are we talking about this angle?
The Nick angle.
So angle of elevation is always formed between the line of sight and the horizontal line. So right now when Nick, we're talking about Nick. So this is the line of sight for Nick.
Got it.
So this angle is 3 degrees. Okay, find the length of the line of sight. So this is what we have to find out. Let's call it X. Here we don't need to use law of sine or cosine. This, you don't need to use line, what was that? You don't need to use law of sine and cosine here.
Oh, do you just do
Because you have a right triangle here. Whenever you have a right triangle,
and then we have to find the hypotenuse, so it's opposite, so that's sine.
sine. First of all, you find out this length. Let's call this point L. What is the length of NL?
Wait, I thought that was 250 feet. Oh, no, that's 240.
Yes, so this is 10. This is 10. 250 minus 10, so this much is 240. 240 is from N to L. Okay, so you have this angle, and for this angle, this side is the opposite, and this side is hypotenuse. So which trig ratio involves opposite and hypotenuse?
Sine.
Sine. So we'll use sine. So
240.
sine of 3 degrees. Sine of 3 degrees is equal to opposite over hypotenuse. So 240 over hypotenuse. Okay. So hypotenuse will be 240 over sine of 3. You can find out sine of 3 degrees from calculator. It is 0.05. 0.052. 240 divided by 0.052.
Wait, I keep getting 4,585.
Getting 4,615.
Okay.
240 divided by 0.052.
I'm getting 4,585 for my calculator.
Really? I'm getting 4,615.
Like, oh wait, do you we're not
Did you
we're not supposed to round until the very end of our calculations.
That's it. That's the answer. But check, just check. Have you entered the angle in degrees or radians?
It should be.
It should be in degrees.
Yeah, it should be in degrees. 250 divided by 240 divided by sine 3. Yeah, I'm getting 4,585.
Really?
Mm.
Okay, I'll show it to you on my calculator.
Okay.
What did you get for sine of 3 degrees?
Sine of 3 degrees is 0.05233. Something.
That's a very long number. Sine 0.0523359,562. So you did not round it off?
We're supposed to round off like 240 divided by sine 3 is equal to, and then we're gonna round from there.
Okay, so 240 divided by 0.0523359,562. Okay, understood. Now I'm getting the same thing. Because I rounded off this number.
Oh yeah, he doesn't allow us.
But if you take this exact number, then you have to round it to the nearest tenth. So it will be 4,585.7.
Yeah, that makes sense.
0.8 because the next digit is 5. Okay. Fire towers A and B are located 10 miles apart. Rangers at Fire Tower A spot a fire at 42 degrees, and rangers at Fire Tower B spot the same fire at 64 degrees. How far from the Tower A is the fire to the nearest tenth of a mile? So first draw the towers. And they're 10 miles apart. Let's call this one A and B. Okay, rangers at Fire Tower A spot a fire at 42 degrees. So if somebody is standing here, they spot a fire at 42 degrees. Let's say the fire is somewhere here.
Wait, the fire's on top?
Yeah, that's right. Then you'll make the angle. For people at Tower A, they are spotting it at 42 degrees. So this angle will be 42 degrees.
Wait, won't the fire be like below the fire towers? So they're gonna spot it down?
Will it be below?
Yes.
Let's make it below then. So let's say that it is somewhere here.
Yeah.
Okay, so then rangers at A. Okay, spot a fire at 42 degrees. So which angle will be 42 degrees?
Near where like the hypotenuse and then even below like where the 10 miles is. Yes.
And then rangers spot the same fire at 64 degrees. Spot the same fire, so this is 64 degrees. Okay, how far from tower A is the fire to the nearest 10th of a mile? Okay, so we have to find out how far from tower A, this distance. Let's call it X. This total distance is 10 miles. So this is X, so this will be 10 minus X.
Wait, that would be x, and then why would the other one be 10 minus x?
Because the total distance is 10 miles. So this much is X. So the remaining will be 10 minus X.
Okay.
And again, you have right triangles. Okay, so what should you do here?
You should figure out the angles first because we already have the 90 angles, and then we can just add them up and then subtract by 180.
Perfect, we already have the two angles. So you can find out this and this.
Yeah.
90 minus 42, 48. And this is going to be 56.
And then we can do law of sines. No, we can't do that. No, wait, we can, can't we? Yeah, we can.
This is going to be 26, sorry. Okay. Law of what?
Law of sines?
You can do that. You can also do trigonometry. You get two equations. You can get one equation from this triangle and one equation from this triangle. Let's call the points A, B, C, D, E. And I'm assuming that the height of the towers is same.
Yeah, I'm gonna assume that too. I
Yeah,
think using law of sines would be easier though. Maybe?
law of sines.
Yeah.
Okay. So your law of sines is A over sine A.
Mm-hmm.
Let's write that. Only red color is visible. A over sine A is equal to B over sine of B. It's equal to C over sine of C. Okay, we have to find out this length. Okay, so you can take this angle. So let's write X over sine of 48 degrees.
Is equal to.
Okay, then you have to take, you can take this side AD. AD over.
Oh, I got 10 minus x divided by sine 56 would work.
But then that's a different triangle. We use the law of sine in one triangle, right?
Oh, okay. Yeah. My bad. So
Okay, but from this equation, you won't get the answer because we don't know the value of AD either. But then you'll have to create two equations. Now we'll create a similar equation for triangle BCE. Okay, so 10 minus x over sine of 26 is equal to BE over sine of 64. Now the good thing is that AD and BE are same.
Wait, sine of 26? I thought it was 56.
No, 90 minus 64.
Oh, my bad.
That's 26. Okay, so how will you solve these two equations? You have to find out the value of x. Okay. you can find out the value of AD from this equation in terms of x. And from here, you'll have to find out the value of BE in terms of x. And then we can equate them because the height of the towers is same.
Mm-hmm.
Okay, so first let's write the values of sine 48 degrees. Sine, sine of 48 degrees. So sine of 48 is 0.743144825 is equal to AD over sine of 42. Wow, this takes a lot of time to write all the numbers. 669130626. Okay, then 10 minus x. Now I think you'll be able to solve this, right?
Uh-huh.
Because this is very tiring to write the numbers.
Uh, uh, so
1147 is equal to BE over sine of 64 degrees. That is it. Oh my God. So from here, AD will be 0.66 divided by this number. I am not doing this. Okay, sorry.
nah, you're good.
Okay. But you understood this, right? From here, you solve for AD.
How would you solve for
Solve
80 if there's only one variable, two variables?
Yes, you don't solve for AD, you find out AD in terms of x. From here, you'll get the value of AD in terms of x. And from here as well, you'll get the value of BE in terms of x. And then you equate both of them because AD is equal to BE. So whatever this is equal to this. And from that equation, you'll get the value of x. So if you have any confusion, I'll take these numbers to the nearest tenth. So this is x over 0.7 equals to AD over 0.6. So we find the value of AD, that will be 0.6 times x over 0.7, that will be AD. And from here, 10 minus x times 0.8 divided by 0.4. That will be BE. Okay, and then you put them equal to each other. So 0.6 over 0.7 times x is equal to 0.8 times 10 minus x over 0.4. And from here, you'll get the value of x.
All right.
Do you want me to solve this?
No, that's easy enough.
Yeah, but you have to do all this work with all these numbers. Like I just showed it to you by rounding them off, but you cannot round them off.
Mm. No, that's easy.
Okay. Okay, do we have more problems?
Yes.
Okay. So you already solved number 1 and 2?
Yeah.
Okay. Number 3, two observers are standing on shore half-mile apart at points A and B and measure the angle to a sailboat at a point C at the same time. Angle A is 63 degrees and angle B is 56 degrees. Find the distance from each observer to the sailboat. Okay. Let's say both of them are at points A and B. Half a mile apart. So the distance between these points is 1/2.
Mm-hmm.
Okay. Angle to a sailboat at a point C at the same time. So with sailboat, do they mean the parasailing thing? No, sailing boat is... Okay, this is on the water. But wait, I don't understand. Where is the sailboat? Where exactly is the sail? Uh, oh, this is the shore, and over here there is all water and water. This is all water. And somewhere here there is a point C. And at point C there is a sailboat. Angle A is 60 degrees, 63 degrees, and angle B is 56 degrees. So let's make the angle. This one is 63 degrees. And angle B is 56 degrees. Okay, we have to find out the distance from each observer to the sailboat. This distance, the slant distance is what we have to find out. This point is C. Okay, so we have to find out AC and BC. And AB is 1/2 miles. Okay. So which law should we use?
I think we should use, so we have two angles and then we need to find the sides. So I think we should use the law of sines.
If you use law of sines, well, in that case, you should first find out this angle if you want to use law of sine. Because if you use law of sine, let's call this side as small b, small a, this is small c. So 60 small a over sine of 63 will be equal to small b over sine of 56. And what will be this angle? Do 180 minus 63 minus 56. Minus 63 minus 56. This angle will be 61 degrees. So this is equal to 1/2 over sine of 61. Okay. Now you can pick two ratios one by one. So if you pick this ratio and this ratio, you'll get the value of A over sine of 63 is equal to 1/2 over sine of 61. From here, you'll get the value of A. And when you pick these two, then you'll get the value of B. Okay. So let's do now. And whatever is your answer, don't forget to write miles in the end because the distance is in miles. So from here, whatever the value of A is, write miles and miles. And in the end, mention that the distance of the sailboat from point A, from the observer A, is this much miles, and distance of the sailboat from observer B is this much miles.
Right.
Okay, number 4. A vertical flagpole is attached to the top edge of a building. A man stands 400 feet from the base of the building. Let's make a building. Let's say this is the building, and a man is 400 feet from the base of the building. Let's say here is the man, M for man, and this is 400 feet. From his viewpoint, the angle of elevation to the top of the flagpole. What?
Oh, I thought the hypotenuse was 400 feet.
No, 400 feet from the base of the building.
See, when it says from the base of the building, I always get confused. Like, when it says from the base of the building, I'm like, okay, so it's at the end of the base, and then that's going to be like the hypotenuse way, or no?
So when you say hypotenuse, that means, do you think this should be 400 feet? Because this will be the hypotenuse.
Oh. Oh, no.
Base of the building will be always on the ground. Okay.
Mm.
Always in these type of questions, whenever you see base of the tree or base of the lighthouse or base of the building, so you have to take the distance from ground level. Okay, because base is always on the ground. So that's why this 400 feet distance is from the ground level. This is the base of the building. So I'll call it B. And this is the flag post at the top. And from the angle of elevation to the bottom of the flagpole is 60 degrees. Now this is, and to the top is 62.5. Here you have to be really careful. So you have to draw the building. You also have to draw the flagpole. Let's say B to F is the building, and then we have to draw a little flagpole. Let's say the green one is the flagpole, okay?
Yeah.
Okay. Now we have to make two angles. So the man is looking at the flagpole. So he's looking at the bottom of the flagpole, and he's also looking at the top of the flagpole. Okay. Now, angle of elevation, it will be which angle?
The angle of elevation. So that's gonna be FM.
You mean this?
No, the other one.
No. Angle of elevation will be this one.
Yeah.
So when you're looking at the bottom of the flagpole, this angle is made. So this is 60 degrees. And when he's looking at the top, the angle is 62.5 degrees. So the bigger angle, this one, is 62.5. So that means this much is just 2.5. Okay. But you don't need that. 62.5. I'll use a different color for the bigger angle. 62.5. Okay, now what do we have to find out? Determine the height of the flagpole. The green length we have to find out. Let's call this point as P. Okay.
And wait, to the top, 62.5?
Top of the flagpole. This point, so the green, you see the green line, that is the flagpole. This point P is the top of the flagpole, and this point F is the bottom of the flagpole. Now, when this man is looking at the bottom of the flagpole, he's looking at point F. So he's making an angle of 60 degrees. And when he's looking at the top of the flagpole, this point, then he's making an angle of 62.5.
Yeah, that makes sense.
So the yellow angle, 62.5, is the angle of elevation to the top.
Mm-hmm.
Okay, this angle is 90. What will be this angle?
If that's 90 plus 60, that's 30 degrees.
So first think about it. How should we approach this problem? I think,
Oh, wait, it's a 30, 60, 90 triangle.
yes, it's 30, 60, 90 triangle. So you can find out the length of FM, the hypotenuse.
Okay, so the opposite of 60, so the leg is going to be x square root 3. I mean, no.
Yeah.
Yeah.
This could be, what will be BM?
BM is x.
BM is X. So you don't need to find out FB. You just find out FM because ultimately you have to find out X. So you need FM.
Yeah.
So FM is the hypotenuse, which is 2X.
Mm-hmm.
So FM will be 2 times 400. So that will be 800. So this is 800. 800 feet. Now consider this triangle, FPM. This angle, can you tell me how much is this angle?
So if that's 2.5 degrees.
2.5 degrees. Okay, and you have to find out X. You can use law of cosine.
Oh, wait, yeah. So because like is that even a right angle triangle? No, right?
No. Now we don't have a right triangle, so that's why we need to use either law of sine or cosine. So let's just focus on this triangle. This is 2.5, and this is 800, and this is X. Okay. Let's call it ABC. This is A, small b, small c. You have to find out x, small c. So
So we can't just use like sine or cos to do this, right? Like put like
hmm,
cos or sine instead of 2.5, or can we do that? Like using opposite angles?
if you use the law of sine, you will get x over sine of 2.5. In any case, you will need either the value of b over sine of 800. Sorry. You don't have any angle, right? Oh, wait, you can find out this angle, Adviti. What will be this angle?
Where? Hmm?
Can you find out this angle?
Oh yeah, you can. That's 150.
150.
That makes so much more sense. Okay.
Now you can find out the third angle.
Oh yeah, 170.5. That's I can't math. 170.5. That is a 9.5.
9.5?
I'm sorry, my brain is not braining. Wait, don't. Yeah, see, I can do this. I can do this. Uh-huh.
Hmm,
Mm, 25, 27.5.
27.5, yes. Okay, so now we can find out. So this angle is 150. This is 27.5. Now we can use law of sine. Okay, so we need x over sine of 2.5 degrees, and take 800 over sine of 27.5 degrees. Okay, so x over sine of 2.5, again a very big number, 0.0436193874.
Wait, can we, when we have a right angle triangle, we can only use cos or sine or tangent to like insert the angle in one of those and then solve?
Can you say the first statement of your question again?
Like when we're using sine, cosine, or tangent, we only
That,
use right angles?
yes,
Ah,
the SOHCAHTOA that you've learned,
yeah.
SOHCAHTOA, this you can only use in right triangles, only in right triangles, okay? But the law of sine and cosine, that is universal law. That works for every triangle. Right triangle, acute triangle, obtuse triangle, for every triangle. But SOHCAHTOA works only in right triangles. And SOHCAHTOA is definitely easier than law of sine and cosine. So
Oh, yeah.
whenever you see right triangles, try to use SOHCAHTOA. And when you don't have a right triangle, when you have acute or obtuse, like this is an obtuse triangle. So here we will use law of sine and cosine to solve the triangle. So this is called solving the triangle. Solving means we are trying to find out all the three angles and all the three sides.
Mm.
Then sine of 27.5, 0.461748613. So 800 times this number divided by this number. 800 times 0.0436193874 divided by 0.461748613. Okay, so x will be 75.57. Do we have to round it? I'll
Um,
round it to the nearest tenth. 0.6
75.6. Yeah, that's what I got.
feet.
Yes, feet.
Yes. Like this is big deal. This is a big deal. You lose points if you don't write the units.
Well, in his class, I don't know. He taught us unit circle, and I didn't understand anything he said, and I just looked it up, and then I just tried doing it, and then I actually understood it.
Hmm.
He explains in the most roundabout way, and then some people cannot even understand it.
Hmm. That's sad. But also, whenever you learn a new topic, the first time you will never understand a new topic. Then you have to spend some time. You have to again rewrite everything, again try to understand everything. And maybe in the second attempt or in the third attempt, We understand it.